Hello everyone, welcome back to Python and for data science. And up to now we have covered pandas, and if you have not watched all the previous videos, it's requested that please cover that first because we'll be using all those concepts now in advanced way. And in today's lecture we'll be basically focusing on the visualization part. What are the different libraries available and what are the different functions available in those libraries which can be used for the data analysis using like visual graphics. And before moving to that, why and what this thing is, let's understand one basic concept about the data. Okay, so we have data, and the data can be divided into two parts. So first is categorical, and the second one we can say as continuous data. So when I say categorical, so basically it's like where the data is in a format that can divide things into different categories or sections. Suppose uh, let's say gender, right? So gender can have two values, either it is male or female. Okay, and we can talk of some other values like whether any event is true or false. So these are categorical values. Okay, you have got one, two, or three. Like it's not that only two category could be there. There can be many more categories, but the thing that I'm trying to convey is your data is grouped on the basis of certain categories. Okay, whereas in continuous type of data, it is any number that is ranging between some minimum and some maximum values. Okay, suppose I have a temperature. Okay, so minimum I'm considering as 0 degree and the maximum I'm considering as 100 degree. So the temperature of water, if I'm start heating, it will cover every single point in this range. Okay, every single point in this range, it could be anywhere between 0 degree and 100 degree. Okay, the boiling point of water. So basically this is freezing point and this is boiling point, but my temperature can range from 0 to 100. It can lie in between anywhere, or it could even go to the lower side, but I'm just considering two points. So the point which I want to convey here is, when it is categorical data, we have some category to divide our data, whereas when we have continuous data, you can see it's something like this with some minimum values and maximum values, and data can lie in between these two ranges. Okay. Now we did series is basically 1D data. Okay, and then we did data frame. So data frame is basically 2D data, like on a bigger scale. Just for our understanding or for this particular class, we're considering the data set as the maximum level to be as 2D data, that is two-dimensional data. Our data can be described by two values here. Let's say x and y. So x and y are good enough to describe the point or the data. And on the basis of this, we come to another point that is called as univariant, and then we have bivariant. And these are two different types of analysis. So when I say univariant analysis, so basically we do it for each single column. Okay, suppose there are multiple columns available. Column A is about age, column B is about weight, column C is about height. Okay, but when I'm talking a univariant analysis, I am focusing only on one. Okay, uni means one, this uni means one. So I'm focusing only on the one particular column, whichever be of our interest, we'll be focusing on that only one column, okay, single column. So what can I do with a single column? Okay, with a single column I can understand how my data is distributed. Okay, suppose we have age here as 14, let's say 14, 21, 18, 17, 18, okay, 20. So this is our data. Now if I have to plot it, you can see we have 18, 17 and 18. So this is going, let's suppose this is somewhere 18, 18, and then we have one here at 17, and then one we have here at 14, and then one we have here 20, and then when we have here 21. So now let's consider a size of bubble. If it is more than once, the size of the bubble gets bigger, so make it bigger for 18, okay, because we have two people. For 17 let's keep it a bit smaller, for 14 let's keep it smaller, 20 little bit smaller. So what we can see here, let's make two for each representing one 18. So what can we see here? Our data distribution, if I talk about distribution, I can clearly see my data is distributed how in this particular area it is highly concentrated, whereas on the either side it is less concentrated. Okay, so if I plot, it could be something like this. So our data is majorly falling into this area. This area is like where the most of the age is falling, and the rest two areas, that is extremities, that is on the lower side, and this is on the upper side. We do have data on the lower and upper side, but our data is more distributed in the center. That is why we are getting a peak value over there. So when we are doing univariate analysis, we basically focus on one particular column, and the kind of distribution that data is giving is find out in that analysis. Okay. Now if there are two different columns, suppose let's take age, not age, but IQ. Let's take it, one column is IQ and the second column as class 10th marks. Okay, now we have to find a relation between column X and column Y. We are doing a bivariant analysis. Bi is basically two variables here. Okay, now we are doing analysis on two different variables. Let's say X and Y. X is representing IQ and Y is representing the marks in class 10th, or the final percentage, you can say. So what we are going to do here, we are going to find a relationship here. In bivariant analysis, we find the relationship between two variables. So how the X is related with Y? What is the relationship between X and Y? Once we try to understand this kind of things, we are actually doing bivariant analysis. Okay, and by comparison, like doing a comparison between two different variables, we come to another concept in stats, and that is called as correlation. So what basically correlation means, you can excuse my handwriting because I'm just trying to write with my hand on the touchpad, so just excuse the writing. So what is correlation? Correlation basically is telling the relation between two variables. How is it like how one variable is related with another variable? So the range of correlation lies between these two numbers. Once we have this, our number correlation factor is between these 0 and -1. So we say our variables are negatively related. Okay, whereas if the variable correlation coefficient lies between 0 and +1, we say our variable is positively correlated. Let's take a live example which we are seeing right now. So right now the temperature is something between let's say 40 degrees Celsius. Okay, it's quite hot. Okay, on the scale of hotness, like how hot it is outside, it's very very hot. We have bright sun here. Okay, but if we go on the lower side, we have cooler sun here. That is in winter. This is winter and this is summer, and we are going to find how this temperature is affecting the sale of ice cream. Temperature is affecting the sale of an ice cream. So definitely we all know that as the temperature increases, as the temperature increases, the sale also increases, because as the temperature is going high, people will start consuming more number of ice creams. So you see, as the temperature is going towards right, we are seeing that sale of the ice cream is increasing. So this is basically a positive correlation. Okay, so one is increasing, the other is also increasing. Now let's see a negative correlation. D is basically for demand and S is basically for supply. Okay, so as the demand increases, supply will also increase. So this is a positive correlation. Okay? But if I want to understand to increase the profit, okay, if I want to increase the profit, what I have to do is, if demand is increasing, I have to decrease the supply. To increase the profit, I have to decrease the supply. Why? If demand is increasing, okay, let's say the price of article, this is the price of article. Okay, if the demand is increasing and we are not able to supply, okay, so what is going to happen? Whatsoever the limited quantity is available in the market, its prices will go up. Okay, it is just assume the case when we had a COVID period and the mass price went high. Okay, so demand was increasing but supply was decreasing. At that point of time, we had negative correlation. This is not some good example. Let me think of some other example where I can show you basically the negative correlation. I think we'll be covering McDonald data set, and in that I'll try to show you if it is having a negative correlation or not. So negative positive correlation means one is increasing, then other is also increasing. Negative correlation is basically when we see one is increasing and the other is decreasing. Okay, so Boyle's law, there is a Boyle's law in chemistry. So PV by T, if you remember the gas law, so pressure, volume and temperature. Okay, so pressure is inversely proportional to volume. As the pressure increases, volume decreases, so we have negative correlation. So this is just an example. Now let's understand, why do we need visualization? What is the impact of having visualization in data science? Okay, so you see, these are some, like a few visual that you can see. Like one is, the first one is bar graph, the second one is scatter plot with a trend direction. Okay, then third one is also a horizontal bar graph, then fourth one is also a line graph, but it is showing a comparison, and fifth one is an area graph. This is an area graph here. Okay, so there are multiple graphs here. This is a pie graph. Okay, and this is a donut graph. At the bottom we have a donut shape like this. This is a donut graph. Okay, this is hierarchy level graph. Okay, and there are multiple types of visualization that we can have to represent our data in a better form. Like uh, there is a statement that says if we present our data in a visual form, the information that is being conveyed from that particular data is more effective than when it is conveyed in just text or some written documented form. Okay, so that is one reason why we come up with the fact that we have to visualize our data. We have to make it more visual, more appealing, so that the data information that it is trying to convey is consumed in a better way. Okay, so suppose I have this whole chart, like whole information written here, and everything is in a text format. It will be very difficult for anybody having very less time to go through each line. Okay, so the other way is to do is represent my information in a visual formation, like in a visual form. Okay? So the importance of visualization becomes great in that sense when it comes to marketing strategy, where you are presenting to some high level authorities, or you are presenting to like CEOs. So in that case, you cannot just go and put the data, complete data set. Okay, I have found this Excel sheet. Please go through it. This is the findings. No, that will not be the case. Since they have very limited time, we have to talk to them in a like very precise way and concise way. Okay. Uh, so in the best way will be to present our information in the form of visuals. Okay, so what is going to be there in the visuals? So we are going to put some charts, we are going to put some uh, graphs over there, so it will kind of show where the trend is going, or whether it is positive direction or negative direction, or we can even do the forecasting in a visual formation. Okay, so the advantages here are that we are in a state, when compared with our text analysis and visual analysis, we have a better analysis here. Okay, and since the visual information is like understood in a faster way, that is why we can take quick decisions and quick actions can be taken. Okay, by just seeing the visual graphs, we can identify the patterns, whether the trend is going into the upward direction or the downward direction, or it is stable. Okay, so there are multiple advantages. These are a few that I have quoted here, but it is just limited. uh, but in reality, like, it is limitless. Okay, so this thing we have already done. Univariate is done for single columns or single variables. Bivariate is done for like more than one, but two actually. And multivariate is also more than one. So here we are not covering just two, we are covering more than two characteristics or attributes or variables. So when it comes to Python, we have already done Pandas. Okay, Pandas is a very beautiful library because it gives us the capability to do data analysis as well as the visual effect. Okay, we can use it for visualization as well. Sorry. So other than Pandas, we have Matplotlib, okay, Seaborn, then we have Bokeh and Plotly. So I do not prefer like first I prefer Matplotlib, then Pandas, then Seaborn. Seaborn is a bit advanced and is much more visually appealing. It looks very good. When you plot by Seaborn, it's much more beautiful. But I prefer Panda because it's quite easy to implement. I'm not saying that Seaborn is hard, it's more or similar. It's up to you, like you can use anything. It's there is no debate here that which should I use. Whatever fulfills your objective, you can definitely go with that. Okay, so to do that, we'll be installing certain libraries. Okay, so I'm installing Matplotlib, Seaborn, Bokeh, Plotly, Chart Studio. Okay. Now I have to import the pandas, so I'll be using import pandas as PD. Now we have these lines which we already actually covered, but I'll explain it a bit again. So suppose your data, you are seeing your data, you are describing, you are checking your data. In that case, the number of
I
columns that
didn't
you can
understand
check
that.
in the output is limited. Okay, so whatever the maximum possible columns that I can see, I'm going to use a display dot max column. So this is going to give us all the columns, maximum column that is possible to display in a screen. Similarly for column width, then we have maximum number of rows. Okay, then decimal formatting. Okay, all those things are done here. Then we are importing numpy. Then for the visualization, we are also going to import matplotlib dot pyplot as plt. Okay, and then also we are importing cbon as sns. Then we have a line command, that is percentage or modulus matplotlib in line. So what this is going to do is basically it is going to give all the plots in the notebook itself. So as soon as you run it, you are going to see the output just below the code. So if you want to do that, you can, or you must include this percentage matplotlib inline. So inline is basically going to make sure that whatever the graph that is being generated from matplotlib pyplot is being reflected in the just below the code. Okay, and then we are importing some graph objects and then plotly. Okay, this is basically for offline mode. Then we have import warnings, and we are trying to suppress the warnings if there are warnings. Warnings are basically non-lethal to the code, means the code will run, but there are some structure problems, but it will not be affecting the codes, but we'll be getting certain warning messages, so we can definitely go and ignore them. So to suppress all those warnings, we'll be using this import warnings, warnings.filter warnings, and in bracket we'll put ignore. Okay, so let's understand what kind of data set we'll be using today. So this is what you this image is basically for the MACD data, which is related to like what is the different categories of meals available. Okay, what is their prices. Okay, and whether it is a cold whether it is a cold one or a hot one. Okay, we can see all those things, right? So just give me 1 second, please. Yeah. So this menu is decided for specific location in India. Whatever menu you are having, so there are high chances it will not be same as in North India and South India. It might have different menus in eastern part of India or the western part of India, or if not, we can take different countries. So if the menu in India is not going to be same as the menu in US, because it is customized on the basis of customer requirement or the customer taste. So we'll be considering two different data set. One data set will be calling as McDonald's menu. So it is going to have the menu. Okay, and then other data set will be having McDonald's store location. So first, that is McDonald's menu, will have these numbers of columns, that is category, item, serve size, energy, protein, total fat, saturated fat, trans fat, cholesterol, carbohydrates, sugar, dietary fiber, sodium, high or low sugar. Okay, and this is the description of that particular column. Similarly, for the location, we have different columns here, and we have different like the description for all those columns here. To import, I'm having I have saved my data into my Google Drive. So to bring Google Drive into this collab notebook, we'll be using from google.collab import drive, drive.mount, and slash content slash drive. If you if you want to know how I did that, so you can see, if you click on this folder icon, you can see this folder here. That is basically, if you do not mount it, it will be here mount drive, and as soon as you click it you will get this code automatically and it will import your drive. And then you can see here your drive option, and then you can open these all, and suppose I want to include this file, so click on this and then copy path. So that is how you can copy the path. I have copied the path and I have pasted here. Okay, content drive, my drive, collab notebooks, dataset, menu.csv, and this is McDonald's store data.xls. So one file is in CSV, so I have used read underscore CSV, and the other file that is for the store one is in Excel file, so that's why I have used read underscore exel, and the format is XLS. So two data set we are making. One is df underscore mcd and df underscore store. Mcd is basically going to have the menu items, all those things. That is this one column on the left, and the store location will have these many columns. Okay. So once we run it, you can see the first one is having, that is the shape. Shape is basically going to tell how many columns, how many rows are there. So menu has 260 rows and 24 columns, and similarly store location has 40 rows and 18 columns. So dfmcd.head is basically going to give top 3 rows to us. Okay, we have category, item, serving size, calories, calories from fat, total fat, and so many. And like that we have total 3, 6, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. You see here we have 24 columns. So I just counted to show you that the shape is basically row cross columns. Okay. So we have dot sample, like in the last session we did dot head, dot sample, and dot tail. So head is basically going to give us top rows, top 5 rows. Sample is going to give any random 5 rows, and tail is going to give us bottom, like last 4 rows. So not 4 but 5 rows. So let's understand univariate plotting, how to do that. In pandas we can have different types of plots. So this is bar plot, and this is line plot, this is area plot, this is histogram, and this is donut. Donut is an exploded form of pie chart. So in pie chart we basically do not have like center part is not removed, this one, but in donut chart the center part is removed. It is similar to donut that you can get to eat. Okay. Now before moving further ahead, there is one crucial thing that you must understand: when to use what kind of graph. You cannot use all the graphs every place. Okay. Each graph has its own capacity, its own uh, like, power to be used. It can represent only a certain set of data, so you must understand when to use what kind of graph, okay, or charts, when to use them. So first let's take bar chart. Okay, this is my bar chart. So this is used to show comparisons. Okay. Comparison between what? So it is basically going to show us the comparison between different categories, and in this case if we talk of data, then it is discrete data. Okay. And then we go for suppose, let's, if I want to convey like the demographic population, how the population is changing by year. So I can say in 2020 we have this population, 21 we have this, 22 this, 23 this. So we are handling discrete data here. Okay. And years are basically our category. Years are different category. On each category what is the count we have, so we can use that. Then we have line chart. Line chart is basically showing us the trend. Okay. And trend is compared or found out on the basis of time. So on one axis we'll be having time, and on other axis a particular column. So we'll see how that column values changes over the period of a time. Okay. Then we have area chart. Okay. So this is used to display changes in a variable over time while showing the magnitude of the change. You see here, this is similar to the line graph, but it is showing us this particular area in a shaded form. So it is going to give us a better representation when it comes to the magnitude. So you can see here the magnitude is quite high and here it is low. So if I want to understand, just let's take a very simple graph of seismic activity or earthquakes. So if the scale is very high, we are seeing here the peak. This means that the scale of earthquake was very high in this. Seismic graph shows that this point here, the magnitude of our earthquake was very high. So this is basically ideal for identifying the trend of a variable while also showing the scale. Then comes histogram. In this thing you have to make bins is basically ranges. Okay, suppose I have to represent the age in a class, so I'll make bins of 10. So what does it I mean, basically I want to convey here is, let's say let's group the students and count. So this particular group is basically going to be said as bin. So first we'll have students from the age of 10 to 15. So this range 10 to 15 is going to be one bin. So all the counts will be represented here by one value. So one bin is how many values are there here. Similarly, second bin, how many values are there? Third, fourth, and fifth. Okay. So what is happening here? So this is used to show the distribution of a continuous variable, ideal for identifying the frequency of values that fall within certain ranges or bins. Okay. Now since this is a donut chart, this is very similar to the pie chart, okay, which is used to display the portion of anything out of whole. Okay. Ideal for showing how much each category contributes to the total. So how much is this contributing, how much percentage is this contributing, how much is this, and how much is this. So that is one thing. Then we have few more, that is a heat map. So that is used to show cross uh, how's one variable related to the other variable. Like if we have multivariate, in that case we can do heat map. So I'll not be doing that as of now because we will be covering first univariate. Okay, so for the bar chart, okay, let's understand what are the different columns available with us. So what I'm going to do is I'm just simply typing df underscore mcd dot columns. So this is going to give us name of all the columns. Okay. So now if I want to find the column df underscore mcd dot, so this is going to give us all the values in the category column. Okay, if I run this, you see these are all the categories available and these are all the rows here. Now if these are all the categories here. If I want limited number of columns, I will not be using this. You see, column and rows one. This is allowing us to see the maximum number of possible rows and columns here. So there is like if I want to understand how many different categories are there, I'll use n unique. So this function is going to give us where like how many different categories are available. So we have 9 different categories, and if you want to see what are those categories, you just type unique. So we have breakfast, beef and pork, chicken and fish, salad, snacks and sides, desserts, beverages, coffee and tea, smoothie and shakes. So these are different 9 different categories. Okay. Now let's see another function called as value underscore counts. Okay. Please do not confuse it with the dictionary values. Okay, so the coffee and tea is like 95 times. Okay. 95 rows we have coffee and tea. Breakfast we have 42 rows. Smoothies and shakes we have 28, 27, 27, 15, 13, and 7 and 6. So this is basically in descending order. Okay, now I want to plot a bar graph. Okay, how to do that? Before doing that, let's find the index. At what indexes are these available? Okay, so indexes is basically nothing but our columns. Okay, unique columns. So either we can write this, or we can write uh, dot columns, or sorry, dot unique. Okay, so that is going to give us this, but by this way we are going to get in a specific order, that was descending order. So that is why we are using value counts first, then we are going for index. Now we have made a index out of this. Now we are going to convert it into a list. That's why we have used to list. So this is going to be converted as a list. Similarly, for y, we are going to put the values. Okay, on x-axis we are going to put the names, and on the y-axis we are going to put the values count. Okay, so here dot values count dot values, let me show you what it is going to give us. So if you remember this, this is going to give us how many values we have for each particular column. But if I write values, just values here, so it is going to give me just the numbers. Okay, 95, 42 and all those. So remember, this is an array, so we'll be using this array as a y value, and for x we have the category names. So we are printing x values and y values here, so it is easier for us to see what things we are having. Then we have this line, figure is equals to plt dot figure, fixed size is equals to 15 comma 7, it's a list. So what basically this line is telling us, it is telling that we are going to make a figure. So figure is basically representing to the plot that we are going to present, and the size of that is going to be 15 comma 7. So to do that we are using a function called as figure, and that is available in matplotlib. So that is why we are using plt dot figure and then fixed size. And remember to use it as a first line, because once the canvas size is set and then we plot it. Okay, we do not make an art on a paper and then try to stretch it. We first take a specific size and then we plot it. Okay, so first we have taken the size of our sheet, then category column. Okay, what are we going to plot? So we are going to plot the value counts here basically, then dot plot, then dot bar. So bar is basically what kind of plot we are going to plot here. So we are going to plot bar graph here. So color, this is a color code which you can like ignore it. If you ignore it, you will get some other color. Let's remove it for time being. Then x ticks, you ignore this ticks and all those things, we can cover it later. At label is basically, okay, let me cover it. So ticks is basically nothing, these numbers that you are getting here, these are the ticks. Okay, these are y-axis ticks and these are x-axis ticks. Okay, and then we have labels. So labels are like, what is this, is the label here, number of items on the y-axis, y label, and x label. Okay, x label is equal to category. Then we have title. If you want to print the title, so it's plt dot title. Okay, so the functions are plt dot title, plt dot y label, x label, x text, and y text. Okay, and then at last, to show the graph we use plt dot show. Okay, now if I run it, you see the color I have removed, so that is why I am getting the default color, and that is blue here. Now if I comment this particular line and I run it, you see the graph size gets reduced now. Okay, but if I want to increase the size here, I'll include this line back, and this 15 and 7 are up to you, like whatever size you want to choose, you can change it. If I make it 20, you can see the size gets a bit bigger. We can also rotate this, since right now it is just perpendicular to the x-axis. We can even make it slant at 45 degrees. We can always do that. So then we have another bar graph here. Okay, the number of items per category, like category is here, and how many items we have got, we are plotting it here. So in that case, what we are going to do is figure size we are taking, then this is our value. Okay, len function we are using, and like dividing the whatever the values here. Suppose in this we had 95, so 95 divided by total number of uh, rows here. Out of all the rows, how many columns each category is having, how many rows each category is having. So this is basically having the percentage. Okay. Then these are ticks. So rotation, as said, we can rotate it, we can keep it 45 degree. So let's see, it is 90 right now. If I change it to 45, it is going to rotate it. Okay. And this np ticks, we are just taking some random variables from 0 0.3 to 0 0.5. Let's 0.5, let's take it 0.8, and then labels, and then plt.show. So this is one simple thing. Okay, let me show you another thing here. So we have df underscore mcd dot, name of the category was category, okay, dot plot dot bar. So this is very simple code. Okay, nothing super critically. Okay, sorry. Out of all those category, what exactly I'm trying to print, like plot on the bar graph. So it's my value counts. So this is just a plain simple line. This is my data frame, this is my column name, and this is the values in my columns, and I'm just plotting a bar graph. So this is just very simple way to plot. Now let's see another line chart. So line chart, as I said, it is going to give us like plotted on over time, or it could be just simply to understand how the flow of the variables is occurring. Okay, so this is being plotted between calories, okay, and variation of energy across different items, how like each items has different energies here. Okay, let me change this a bit. So on the x-axis we are plotting line graph for the calories. Okay, so we have a column here, calories. Let's change it to total fat, and now let's see how it's okay. So what happened here is I'm going to plot the total fat on a line graph here. So that is why I'm using my data frame, then my column name, then dot plot dot line. Okay, so that is what I'm using. In this I'm just applying everything line on line graph, and so dot value counts I'm not here using here, because I'm just This is a numerical value. I'm just going to plot it on a line graph here. Okay. Now if I change it to some non-numerical values, so let's call it category, and if we run it, so it is throwing us error because we cannot plot graph over the category because it is having some categories like breakfast and all those things. So we should have some numerical values here. So that is why I'm going to change it to total fat or any numerical values here. So this is how we plot a line graph. Okay. Now let's see an example of area plot. So this is name of my data frame, and this is total fat percentage daily value. This is name of my column dot plot dot area. Okay, as simple as that. Now if I plot it, you see this is something that I'm getting under area. For histogram, we have to choose the bin size. Okay, so bin size, I'm creating a bin first, and that is having 0, 50, 100. So we are using it as bin size. So bin will also be an argument here. So calories of dfmcd dot plot. Then what kind of plot we are plotting? We are plotting histogram. In histogram we have arguments as bins, and so this is my bin size, and color I'm going to keep as brown. Now if I do that, what I'm going to get here is it looks red but it is dark brown basically. So 0 to 50, 50 to 100, 100 to 150. So this is what I have made my bin size. So combine the data on the basis of this. So group 0 to 50 data in one group, then group 50 to 100 data in another group, 100 to 150 in another group. So that is what a bin size is. Then we have KDE plot. What KDE plot is, you have to use dot plot KDE. So you get something like this. It is like a line graph showing the density. Okay. When we want to density, we use KDE plot, and the syntax is dot plot dot KDE. Donut is already told like what are the donut size here. So suppose we have category here. If you run it, you see 9 categories are there, and all the categories we have already seen. Okay, now we have value counts, like each category how much percentage it is occupying. So you see I have plotted it in a percentage wise. Okay, now dot plot kind, what kind of data I'm going to plot? I'm going to plot pie graph. Explode is basically what I'm doing is this gap here you see is the explode. Okay, and this is the percentage data which we am getting here. This is for this 10.4, you see one digit here, total 4 digit 3.1 f, and then we have wedges props. Okay, and then we have dictionary here, width, and shadow is equals to true. If you make it false, you will not get the shadow at the bottom. Start angle is 160. Okay, just see here the beverages is here and 10.4 here. If I make it 100, and you see the change here, did you see? Earlier it was beverages were here, now it is shifted to here. So what is happening? It is rotating our graph. Okay, so this is what. So there are multiple options inside each. So let me show here. Okay, so we have df underscore mcd. Okay, whatever column, suppose category dot, then we have plot dot. So what are the different plots available here? You can see area, bar, bar h, box plot, density, hexpin, kde, line, pie. So all kind of plots available, you can see it at the bottom here as a suggestion. So I think we'll be stopping the lecture today at this point only, where we have covered all the univariant analysis, and tomorrow we'll be covering bivariant analysis and what are the different graphs available to plot such cases where we can plot and understand two variables relationship or correlation, and what are different graphs that we can use for correlation set. Thank you so much.